All right, so last time we were in section 4.4, so we were kind of reviewing logarithms before we learned how to take the derivative of logarithms. All right, so these should be very quick. So 1a, log base 3 of 3 is 1, right? Because you can say equals x, and you can do that little trick, like switching from log form to exponential form. So 3 raised to the other side equals what's left, 3. So 3 to the x equals 3, x would have to be 1. But you guys should know this without doing any of that work. You should just know that that is equal to 1 because it's the inverse property. So next one, I have 3 raised to the log base 3 of 8. 8. Log base 9 of 81. 2, because this is log base 9 of 9 squared. Log base 9 of 9 cancels to 1, right? 2 goes to the front, so it's 2. Are you guys remembering all of these? Hopefully. All right, next one. So log base 9 of the square root of 3. Okay, kind of. You're thinking 3 to the 1/3. It's close, but not quite. So let's go ahead and write x here. So if I have 9 to some power equals the square root of 3, that's 3 to the 1/2. How is 3 related to 9? It's the square root, so that's 9 to the 1/2 already to the 1/2. So 9 to the x equals 9 to the 1/4, so x equals 1/4. See how that works? Now you could use your calculator and do change base property, but if this is on the non-calculator section, then you need to know that. Okay, next one. I have 2 separate logarithms and they're subtracted. What do I do? I do what? I combine them, but how do I combine them? Division? Yes, you guys are so quiet. Log base 4 of 192 divided by 3 is 64. So we're thinking 4 to some power equals 64. So what would that power have to be? 3. Okay, next one. So I have subtraction and I have addition. So when I combine, the subtraction part is going to be division, so it's going to be 6 over 15. And then the multiplication part is, or the addition part is multiplication. So you can say times 20 like that, or you could put the 20 on top with the 6, right? So times 20. So this is log base 2 of 120 divided by 15. You guys can reduce if you're not sure. Divide by 3. 40 divided by 5 is 8. So I have log base 2 of 8, so 2 to some power equals 8. 3. Okay, when I see 1/2 of log of 16, what does that mean? Yeah, it's log base 10 of 16, but then what about the 1/2? 16 to the 1/2, right, which is the square root of 16. So you're really putting in log of the square root of 16 into your calculator. So now these are the ones where you can use your calculator. So round to 3 decimal places. So log of the square root of 16.
It's 4.
Log of 4. Pretend I know what the square root of 16 is. So log of 4 is 0.6. Was that Victoria that said that first?
Yeah, kind of Victoria.
Okay. So 0.602. All right, how about this next one? What's it? 2. 11 to what power equals 121? 2. Can we do the next one in our head? No. You kind of think about what it's between, right? 2 to the 5th would be more than that. So it's probably some number that's a little bit less than 5. All right, so log base 2 of 30. I can't put log base 2 into my calculator, so I need to switch it. So change a base gives log of 30 over log of 2. And you could have changed it to any base. We use base 10 because we can use our calculator. You could also do natural log of 30 over natural log of 2. You get the same answer. Make sure you put your parentheses in the right places. You should get 4.9068, so 907, or remember on the AP Calc exam you can truncate, so you could also have 4.906. So truncate means chop off. J, log base 8 of 8 to the 2x minus 1. 2x minus 1, that's it. Next one. 3. Last one. 7. All right. 2a, expand the logarithms. So when it says expand the logarithms, it means separate into separate logarithms. Now, this is going to be really important with something later that we do called logarithmic differentiation. Scary, huh? All right, so we're going to break it up into log base 8 of 5 plus log base 8 of y squared. And then that y squared, we know that we can pull powers to the front. So it's going to be log base 8 of 5 plus 2 log base 8 of y. Okay, now for the next one. So I have division and I have multiplication on the top. So I'm going to have log of x squared plus log of the cube root of x minus 1 minus log of 2x minus 1. That's how I started out. What else do I need to do? Bring the 2 to the front, and then anything else? The 1/3, right? Because a cube root is really a 1/3 power. So that means I have plus 1/3 log of parentheses x minus 1 minus log of 2x minus 1. And people always want to try to distribute the log. They want to say it's log of 2x, or minus log of 2x plus log of 1. See what I'm saying? Like they try to multiply this log n. You can't do that. Right? It's log of something. That's called the argument. Just like sine and cosine, they have the argument. You can't separate that part. Okay. Combine the logarithms. So I have natural log of 6 plus 3 natural log of x plus 2 natural log of x squared minus 2. Okay, so first step, we're going to bring those powers up. So I'm going to get natural log of 6 plus natural log of x cubed plus natural log of x squared minus 2 squared. So when I combine into 1, it's going to be the natural log of 6x cubed times x squared minus 2 squared, like that. Yes?
The natural log has base e.
Yes.
Right?
Natural log is base e.
Wait, I'm not quite sure what it is.
How we got that? Okay, we're using the rule where we said log of a plus log of b is log of a times b. So we just had 3 separate logarithms that were added together. So we then multiplied. Let's see.
Oh, we just pulled the natural log out.
I wouldn't use that term I wouldn't say pull the natural log out because it's not really like you're pulling it out.
Oh, you're just combining. Okay. Well,
Yeah.
Okay. Yeah.
All right, b. So I have log base 3 of y plus 1/2 log base 3 of 81 plus 2 log base 3 of x minus 2. Okay, so take those numbers out front and raise them, make them your powers, right? Okay, so I'm going to have log base 3 of y plus log base 3 of 81 to the 1/2 power, so 9, plus log base 3 of x minus 2 squared. Last step, combine. So log base 3 of 9 times y times x minus 2 squared. Yes?
You can't simplify the log as 3 of 9 to 2.
Oh, yes, you could. That would be good. So Victoria just said, can you make this 2? Yeah, so let's actually do that. So this is going to be 2 plus, and then we'll combine the other 2. So log base 3 of y times x minus 2 squared. And that would probably be the answer that they would have like in a multiple choice section. A more precise answer. All right, 4, find the inverse function for y equals log of 1 plus 1 over x. So since there's no little base, it's log base 10, right? Okay, so I have y equals log base 10 of 1 plus 1 over x. How do I switch that into exponential form? Yeah, it'd be 10 to the y equals blah, blah, blah. All right, so if I'm finding an inverse, I'm going to switch my x and my y values. And I'm going to solve for y. So we do that by switching to exponential form. So it's 10 to the x equals 1 plus 1 over y. Subtract the 1 over. And when I see 1 over y, that means take the reciprocal to get y. So I'm going to take the reciprocal of both sides. So I'm going to have 1 over 10 to the x minus 1 equals y. Or you could think of cross multiplying if you want. If you cross multiply, you'd have y times 10 to the x minus 1 equals 1, and then divide by 10 to the x minus 1. Do you see what I'm saying? Same thing. All right, so that's y, so that's going to be my f inverse. So f inverse of x equals 1 over 10 to the x minus 1. So you now know how to take inverses of logarithms too. All right, solving. There's a lot of review of logarithms. Remember, this is a whole chapter now for 2, so to do all in one section. All right, so 5a. So I have 9 to the 8 minus x equals 27 to the x minus 3. Yes?
I have a quick question. So in the last part, we had the inverse function. How is that different from what we did like in the very first part? When we found the inverse function of
It's the same method, like switching x's and y's. Is that what you're talking about?
oh yeah, never mind.
And then solving for y. All right, so first example. So in this case, you could take log of both sides, natural log of both sides, but what's the easiest thing to do in A? Yeah, what would you do?
Don't you just multiply 8 minus x times 3?
Almost. It's not really multiplying by 3.
Well, that's the same base.
Yeah, make them both base 3. So this is 3 squared to the 8 minus x equals 3 cubed to the x minus 3. So now they have the same base. They're 3 to something equals 3 to something. So it's going to be 3 to the 16 minus 2x, so multiply your exponents, equals 3 to the 3x minus 9. So now that we have that, if you have 3 to some number equals 3 to another number, those two numbers have to be equal. So you can now say 16 minus 2x equals 3x minus 9, and we solve. You should get x equals 5. Part B, though, we can't do that. I can't do 4 to some power equals 5, right? It's going to be kind of weird. All right, so when you see this, you can switch it to log form. So that's the first way. So you could do log base 4, 5 equals x minus 1. Remember our little 4 raised to the other side equals 5. That's how you can check. Okay, so that's switching. And you can solve it out. How do we do log base 4 of 5? Yeah, it's just log of 5 divided by log of 4. And then add the 1 over. So I get 1.16096 equals x minus 1. So I add the 1. And I'm going to round to 3 decimal places. So I'm going to get 2.161. Or you could have 2.160 if you truncate. All right, that's the first way. The second way is to take any log of both sides. So a lot of people get really stuck on that's a 4 raised to something. So they should do natural log, or they should do log base 4, which would be exactly what you just did. It's switching it to switching to logarithmic. Do you see if I took log base 4 of both sides? But the beauty about logarithms is you can use whatever log you want. Really, the only thing that matters is that you're using some kind of logarithm in order to drop that exponent. So since the variable is an exponent. So I always do natural log. So I would do natural log of 4 to the x minus 1 equals natural log of 5. So now that you've taken the log of both sides, you can drop exponents. That's the whole point of doing it. So you get x minus 1 times natural log of 4 equals natural log of 5. Divide by natural log of 4. And now you're to that same point you were before, because whenever you do your change of base, that is the same as that. It could be log base 2. It doesn't matter. Any base would be the same. So you'll get the same answer. All right, so you guys try C. So try C and then also try D. All right, so the first one you can do natural log of both sides if you want, or log base 7. It doesn't really matter. The negative x goes to the front. Divide by natural log of 7. And then make it the opposite. So natural log of 21 divided by natural log of 7. Is that what you said? Negative 1.565. Yeah. Yeah, it can be 4 or 5, so you can round or truncate. All right, the next one, so switch to exponential, so 6 to the negative 1, right? The base of the logarithm was 6, raise it to the other side of the equation, equals 2x minus 1. So 1 over 6 equals 2x minus 1. So do 1 over 6, add 1, divide by 2. Oh, crap. I hit the wrong button. Yeah, 7/12. Or you could have 0.583. Okay. Next one, when you guys see two separate logarithms, what do you do to start it out? Combine with what operation? Division, because they are subtracted. Then you switch to exponential, so 4 raised to the 1 equals what's left. So 4 to the 1 equals 100 over x plus 1. So 100 divided by something equals 4. So that something has to be 25. Kind of skipping some steps here. So x plus 1 equals 25. So x equals 24. How about f? What did you hear? Yes, bring the 3 to the front. So you get 3 log base 5 of x equals 6. Divide by 3, so I get log base 5 of x equals 2. Switch to exponential, 5 squared equals x, so 25 equals x. Now if you had not done that, if you had just switched it to exponential to begin with, you'd have 5 to the 6th equals x cubed. So 5 to the 6th, and then you take the cube root. You should get the same thing. But be careful doing that, because sometimes if this had been like x to the 4th and not x to the 3rd, you would get plus or minus, right? But you want to make sure that when you go back and check your answer in your original, you're not getting a log of a negative number. You can't take the log of a negative number. Okay, only logs of positives, or not even 0. Okay, next one, so multiplication. So I get log base 12 of x times x plus 1 equals 1. So 12 to the 1 equals x squared plus x. So this is one that you would have to factor. I'm going speedily. So you should get x equals 3 and x equals negative 4. Now go back into your original. If you were checking, if you check, you have log base 12 of negative 4. So go ahead and try to do your change of base on that. So you'd have log of negative 4 divided by a log of 12. It says error, non-real answer. Okay, that's because you can't take the log of a negative number, like I was saying. Basically, if you had 12 to some power equals negative 4, you can't have 12 to some power equaling a negative 4. That's not possible. So that's why it's a non-real answer. All right, so before I set you guys loose, you got about 6 more minutes. I want to show you some derivatives. Okay, we're going to talk more about this later, but if you guys wanted to start on your 4.4 homework over the weekend, I figured I'd show you what these derivatives are. So the derivative of e to the x is e to the x. It's the easiest one in calculus. Don't you guys like that one? Derivative of e to the x is e to the x. Basically, it's saying that the slope of e to the x is increasing at the same rate as f of x, as the original. So very strange. The slope is the same at each point. The slope is the same as the y value at each location. All right, so if I was gonna differentiate, let's say I was doing part A, so 1A. Oh man, it's yellow. All right, so go ahead and do your product rule. Sorry, I just have to have the yellow screen here. All right, so the derivative of the first, so 2x plus 5 times e to the x. Plus, keep the second part, or the first one normal. And now take the derivative of e to the x, which is e to the x. So in these e to the x problems, you should always pull out the e to the x. So see how they both have e to the x as a factor? So you'd have 2x plus 5 plus x squared plus 5x. So your most simplified form would be e to the x times x squared plus 7x plus 5. So that's how you should leave it. See how you'll always have the e to the x in both of them. All right, let's try another one. So let's say if I have natural log. So the derivative of natural log of x is 1 over x. And that should be something that you guys were kind of questioning for a while, because you guys knew like the derivative of x squared, the derivative of x is 2x, 1, x the negative 1 went to negative 1, x the negative 2, which is negative 1 over x squared. And some of you guys probably questioned, like, oh, this is x to the 1 power, this is x to the 0 power, but then this is x to the negative 2 power. What happened to the negative 1 power? Where did it go? So it came from the natural log of x. So the derivative of natural log of x is what gives you a negative 1 power. All right, so if I'm differentiating, so let's say number 1. So if I have natural log of x squared plus 10. So this is a chain rule. We don't have just x here. So my derivative of number 1 would be 1 over whatever that was, x squared plus 10, times, chain rule, 2x. So we'd leave it as 2x over x squared plus 10. Speaking of chain rule, a lot of you guys missed the homework problem. It was like tangent of 4x, what's the derivative? And you guys remember the derivative of tangent was secant squared, so you had secant squared 4x, and then you stopped, times 4, right? That would be the derivative. Derivative inside, don't forget it. Okay, so a lot of you guys missed that one. It was one of the multiple choice questions at the end of 4.1. Yeah, Catherine?
On the derivative of the natural log, so is x squared plus 10 our x? Is that what we're saying?
Is what?
X squared plus 10 our x, is that why it's 1 over
Yes.
x squared plus 10?
Yeah, that's our inside part, right? Okay, so number 2, so if I have f of x equals cosine of natural log of x, now this is our inside part. So my derivative is going to be, anybody have a guess? Quietest class ever. Negative sine of natural log of x times 1 over x, exactly. So you can leave it like that, or you could do negative sine of natural log of x, and then all of that over x, like that. You guys want to try another one? So 3. So y equals, so we have natural log of something, so that's like a u or an x or whatever. So if I was taking the derivative of a natural log of something, I do 1 over that something. And then the chain rule, so times the derivative of that something. So what's the derivative of sine squared? 2 sine of x times cosine of x. Do you guys all see that? It's a hard one. Because sine squared, let me write it like this. That's what sine squared is. So its derivative, you bring the 2 to the front, so 2 sine of x to the first power times the derivative of what was inside, so times cosine of x.
So can I do the chain rule twice?
Yep, chain rule twice. So you get y equals 2 sine of x cancels with one of the sine of x's. So you get 2 cosine x over sine of x. So cotangent, right? So that's y prime, by the way. So y prime equals 2 cotangent of x. Okay. And let's go to the other ones. Okay, the other ones, these come from the change of base formula. So if I have log base a of x, that's natural log of x over natural log of a. And a is some number. So think of pulling that number out to the front. If I have 1 over the natural log of a times natural log of x, how would you take the derivative of that? So think of the 1 over natural log of a as being a number. So assume it's like 5. How would you do 5 times natural log of x? 5 times the derivative of natural log of x, which we know, right? It's 1 over x. So that means that the derivative is going to be 1 over the natural log of a times 1 over x. Do you guys see it? So it's 1 over the natural log of a times 1 over x. That's where that came from. So 1 over x natural log of a. And then the last one's kind of hard. The derivative of a to the x is itself, kind of like e to the x was itself, but times natural log of a. So that's why e to the x was just natural log of e, which is 1. All right, so you guys can definitely start your homework. Let me know if you guys have questions. So your 4.4 won't be due until Tuesday probably, Wednesday maybe. And you guys have your bingo, which is due Monday. So bingo's due Monday because that's all review of logarithms.